So now let's finish off with some pathways. We want to look at these ascending and descending pathways. So we'll do our skull, our foramen magnum, our spinal cord, down to L1. Here's our hips. And then we had extension of the lumbar vertebrae, sacrum, coccyx. So what we want to just look at is just defining these pathways. So this is our, let's change this picture just a little bit. Let's say this is the skull. So this is the foramen magnum where this is coming out of. And then this would be our spinal cord. And then I'd need my cerebrum, my cerebellum, my spinal cord to my medulla, to my pons, to my midbrain, up to the thalamus, hypothalamus, epithalamus with the pineal gland. Okay, so now we can just kind of identify where we're at with these things. So this first ascending pathway, and remember we're going to have sensory information come in through that posterior aspect of the spinal cord and then go up an interneuron to the brain. So this first one we'll do is, these are ascending pathways. So this first pathway that we'll do is non-specific ascending. So this is information about anything. This is just basic information, basic stimuli information. So some examples that he talks about are pain, temperature, coarse touch, this uses a 3-neuron chain. And information can go to the reticular, or to the cortex of the reticular formation. So we talked about this reticular formation in the brainstem earlier on, and so we can get this information. So let's say basically someone's pushing on us with this coarse touch, right? So coarse touch are these big movements. So someone's not like pressing your right pinky toe with their finger, instead they're just shaking your leg. So big coarse touch. So what's going to happen? We talked about this during sleep. If we get enough sensory stimulation from whatever this is, whether it's light, whether it's, so someone can shine a light in your eye, someone can shake you, someone can blow an air horn in your ear. Regardless, we're going to send that signal up, and then we can activate that reticular activation system, which is going to wake up our cortex. So all we're saying is this non-specific path is what we're going to use if this information is going to wake up our cortex through that reticular activation system. So non-specific 3-neuron chain can activate the RAS. This path decussates at the spinal cord, which means it goes to the other side. So let's say information is coming up from my left foot. It's going to get to the spinal cord. That information is going to decussate over to the right side. So decussates in the spinal cord. So how is that different? Let's see if I can copy this picture over. How is that different than a... How is that different than... Oh, dang it. Than a specific ascending pathway. So what... Basically, we want to look at, like, what kind of stimuli is this going to be specific to? So things like light touch. Things that take a lot of detection. So light touch. Stretch is a very specific thing, right? We want to know how stretched out our muscles are. Vibration. So it sends information about a single type of sensory information using a single type of sensory receptor. And I wouldn't crush yourself right now with these pathways. Once we get into sensory, like we do entire sections on sensory, motor, special senses. So you'll get a better idea of how this stuff is working later on in the unit. And these are going to decussate at the medulla oblongata. So what does that mean? It means that we'll have information coming in from this dorsal root ganglion. Maybe it's the left side. It's going to travel up an interneuron on the left side. Once you get up to the medulla, it will cross to this right side and then continue its journey. The last one we want to talk about are spinocerebellar tracts. So we've actually already talked about this. Sensory information is coming up the spinal cord and going to the cerebellum, because the cerebellum, so it's sensory information about visual, so visual receptors are sending information, proprioceptors, equilibrium receptors, and all this information is coming straight to the cerebellum, because when the motor cortex wants to do something like do a tap dance or something and we need specific movement, we say, hey, we want a tap dance, send that message down over to the cerebellum. Cerebellum integrates all the sensory information about the world around you, and cerebellum says, this is how you should do this action, sends it back up to the cortex and then down the spinal cord through a motor neuron, or out a motor neuron. So these spinocerebellar tracts, these are going to the cerebellum. They don't have to go through the cortex. They may or may not involve a third order neuron. So we'll talk about third order neurons in a second, but those are located in the thalamus. So sometimes we have tracts coming from the spinal cord straight up to the cerebellum. Sometimes that information goes up to the thalamus and then back down the brainstem and over. So that's why, again, when we did the brain earlier, I said we're not really going to do very specific neurocircuitry pathways, because I think you could do a whole class just on that. So spinocerebellar tracts don't decussate. And just give me a sec on these third order neurons I'm about to do first, second, and third. So this conveys sensory information, but not consciously. What does that mean? Sensory information is coming up to the cerebellum, and it conveys the information because it's going to refine that skeletal muscle contraction that the motor cortex wanted to do. So it's integrating what it's getting from these sensory receptors into our motor activity. And remember, these do not decussate. So if we have ascending pathways, then we have descending pathways. So we'll talk about two descending. We've got the direct, or the pyramidal system. So these are going to regulate fast or fine skilled movements. This is a 2-neuron system. So you have an inner neuron. Actually, let me do green for inner neuron. You have an inner neuron coming from the motor cortex down the spinal cord, and then you have a motor neuron that's coming out of the spinal cord going to your effector organ. So we have, that is our direct or pyramidal, and then we also have an indirect or an extrapyramidal system. What does that look like? So this is going to work with our axial muscles. And these are going to regulate balance. And coarse limb movement. All right, cool.